Hey everyone, I am Miss Hu, your physics teacher. In this video, we are going to be learning about gas pressure. We will be specifically learning about the kinetic particle theory and how it relates to gas pressure. Now, first things first, what is kinetic particle theory? To understand kinetic particle theory, let's first recall what we do know about the kinetic theory of matter. The term kinetic is related to movement. So the kinetic theory of matter states that all matter is made up of tiny, discrete particles which are in constant and random motion. This applies to everything that is matter, whether it's solid, liquid, or gas. So tiny, discrete means they're really small and they're all individual particles, all of which are in constant motion. So for example, for solids, they're still moving but on the spot. For example, they are vibrating. Liquids and gases are not only vibrating but they can also move, and they move in random directions. So this is generally what the kinetic theory of matter states. Now, the kinetic particle theory applies for all solids, liquids, and gases, but in this lesson, we're going to focus on the kinetic particle theory of gas. Similar to the kinetic theory of matter, it states that gases consist of very small particles and they are constantly moving in completely random directions. For this lesson, we will be focusing on the kinetic particle theory and how it relates to gases because we are going to be learning about how gases apply pressure. So, how do gases apply pressure? Now, based on the kinetic particle theory of gas, we now know that gases are made up of very small particles that are constantly moving. And because they are constantly moving, they will keep colliding and bouncing off surfaces and the walls of the containers. Do they collide with each other? Yes, they do. However, when we measure pressure, we're only measuring the pressure based on the collision of the gases against the walls of the containers. Now, before we move on, let's just go through a little bit about pressure. So, you should have learned about pressure in an earlier lesson. And if you'd like to know more, please watch my video about pressure. For now, we're just going to go through a really quick overview. And as you may recall, pressure is force per unit area. The formula here is P equals F over A. So if we're looking at pressure of solids, the force in this case is the weight of that solid. The area refers to the area in which that object is in contact with the surface. This object has several different surfaces on which we can rest on, say, a table. If you rest the object on its larger surface area, a larger area means that the force is more spread out, therefore it has lower pressure. However, if you place the object on a smaller area, the weight is concentrated on that smaller area, which means that the object will be exerting higher pressure on that small area. Now, if we look at liquid pressure, if you can recall, is measured using the formula P equals rho GH, where rho is the density of the liquid, G is the gravitational acceleration, and H is the depth at the point where we're measuring within the liquid. Now, liquid pressure does not depend on the volume of the liquid, the size of the container, and it's not like with the solids where we look at the area in which the liquid is acting. If you look at the formula, liquid pressure only depends on the density of the liquid, the gravitational acceleration, and the depth within the liquid, which is basically the formula. So these are the formula to calculate pressure for solids and liquids. Here's the thing, gases do not exert pressure the same way as solids and liquids. So why are we going through this? This is because when we look at pressure, we have to understand the difference between how solids, liquids, and gases exert pressure. So how do gas particles exert a pressure? In this case, we will still be referring to the pressure formula, which is force per unit area. This is a general formula for all forms of pressure, and yes, it applies for gas pressure as well. So how gas particles apply a pressure is actually due to the collision between the gas particles and the walls of the container. This collision produces a change in momentum. The rate of change of the momentum is the impulsive force between the gas particles and the walls of the container. As you can see from the formula, pressure is force per unit area. Therefore, the gas pressure is the average impulsive force per unit surface area of the container. So if you are required to explain how gas particles exert pressure in the container, you can use this process. First, talk about how the collision produces a change in momentum, which leads to the rate of change of momentum, representing the impulsive force. And the gas pressure is the average value of this impulsive force per unit surface area. Now, remember that gas pressure is due to the collision of gas particles with the walls of the container, not due to the collisions between gas particles. And this is because when we measure gas pressure, we're actually measuring the pressure based on the collision of the gas particles with the walls of the measuring device. What are the measuring instruments that can be used to measure gas pressure? We typically use a device known as a Bourdon gauge, or also known as the pressure gauge. Another device that can be used is the manometer, also known as a U-tube. It's called a U-tube because it's shaped like a U. The device that's more commonly used is the Bourdon gauge or pressure gauge because it's very easy to use. All we need to do is hook up the gauge to the container which contains the gas, and the value can be read immediately from the scale on the gauge. However, because it's so easy to read, there are not that many questions on the gauge. So more exam questions are asked based on the manometer or the U-tube because learning to read this can be a little bit tricky, which is why exam questions are based more on this device. In this video, I'm not going to go through how to take measurements or solve questions with the manometer, so please watch my video where I explain how manometers work and how to solve questions. For now, that's the end of the lesson. So if you found this lesson to be educational and helpful, please click like and subscribe for more lessons, solutions, and exam strategies from your physics teacher, Miss Ho. If you would like an updated list of lessons and videos from me, you can also check out my website at physicsrocks.com. Happy studying!